Hi, so I'm going to go through the solutions to the practice exam in a video because I want to kind of give you my commentary and I want to give you some tips. I'm doing this to help you maximize your partial credit on the exam tomorrow. Because I know a lot of you are going to be nervous and you're going to make some minor mistakes even though you know how to do the problem. And so I want to be able to find those minor mistakes and be able to give you partial credit. So you could get the wrong answer but still be using the right method. And I want to make sure you get credit for all of that. So I'm just going to give you some tips on how to write things up. Also makes my grading go a little more quickly because it doesn't take me as long to find your thinking. All right, so let's look at the first question on this practice exam. This one says the entire graph of the function f is shown in the figure below. Write the domain and range of f using interval notation. So remember, the domain of a function is all the possible inputs or all the x coordinates. And so we're looking at the graph, and so we want to be able to write down in a compact, efficient way all the x coordinates that appear on this graph. And we can't possibly list them all because it's kind of an infinite set. So let's look at how far to the left and how far to the right this graph goes. It doesn't go on forever. It has sort of an ending point and a beginning and an end. But notice the beginning and the end are open circles. So that means we're excluding a point there. So looking at just the x coordinates, we can see that we're going from -4 up to +2, and I've kind of highlighted it on the x-axis there. But we're not going to include -4 and +2. So how do we write that in interval notation? In interval notation, we use regular sort of round parentheses to say we're not including this endpoint. So we write parentheses -4, comma, +2, and then parentheses. It kind of looks like an ordered pair, but because of the context, we know we're looking for the domain of a function. We know that this is actually an interval, not an ordered pair. So it's the set of all numbers between -4 and +2, but not including -4 and +2. That's the open interval. Okay, so what about the range? So now we look at how far down and how far up the graph goes, because we're looking for all the possible y-coordinates, all the y-coordinates that appear on this graph. So we can see that the lowest is -2 and the highest is +4. But because of those open circles, we're not actually including -2 and +4. So once again, we have an open interval. And so we write parentheses, -2, comma, +4, and another parenthesis. And so we're saying this is a set of all numbers between -2 and +4, but not including -2 or +4. And that's it on that one. So let's look at number 2. So number 2 is our first word problem. And notice I give you instructions. Use algebra to solve the following problem. And please circle your final answer. I hope you circle all your answers, but it's particularly important in word problems because people sort of are kind of nervous and they find an answer and then they just move on and forget to circle it. And sometimes it's hard for me to tell if you've reached an answer, or you might have multiple things written down and I can't tell which one is your answer. So make sure you circle it. But the important part is use algebra to solve the problem. And that's a reminder that this course is about using algebraic methods to solve real-world problems. It's one of the student learning outcomes. So that's what I'm assessing on these word problems. And so what does it mean to use algebra? It means you're going to use variables and equations. And you're going to solve the equations to answer the question. So I know that some word problems are so simple that you can just do a bunch of scratch work and come up with the right answer, but you're not going to get credit for that if you do it that way. You're going to have to use some algebra. So the first thing you want to do is write down what your variables represent. And even if that's the only thing you do, you'll get credit for that, okay? And you'll lose points if you don't do that. So let's read the problem first. It says 2 factory plants are making TV panels. Yesterday, plant A produced 2,000 panels. 5% of the panels from plant A and 1% of the panels from plant B were defective. How many panels did plant B produce if the overall percentage of defective panels from the 2 plants was 2%? So there's a lot of information going on here, but the first thing we're going to do is write down what our variable or variables represent. So to do that, we look for the thing that we're asked to find. And it's usually in the last sentence. And so here it says, how many panels did plant B produce? So that's going to be my variable. So I want you to write down what your variable is and exactly what it represents. Now, I don't want you to say, let x equal b, or let x equal plant B, because x is a number, not a factory, okay? So be precise. So you can say, let x equal the number of panels that plant B produced. Or let x represent, okay? You don't need to use the equal sign if you don't want to. But it's a number of panels. Okay, so now the next step is to set up some kind of equation. So let's reread and see what information we can use. So it says at the end, if the overall percentage of defective panels from the 2 plants was 2%. So let's set up an equation that represents the number of defective panels in 2 different ways. And then we'll set those 2 different ways equal to each other. So there's a number of defective panels from plant A, and then a number of defective panels from plant B, and then there's the total number, and it's the defective panels from A along with the defective panels from B that gives us that total number. So 5% of the panels from plant A are defective, so that's 5% of 2,000, right? And 1% of the panels from plant B, well, that's 1% of X, because we don't know how many panels came from plant B. That's why we called it X. And together, this gives us the total number of defective panels, which we're told is 2% of all the panels. Well, how many panels were produced altogether? Well, 2,000 plus X, 2,000 from plant A and X from plant B. So this is our equation. So let's write it without all those words and all those percent symbols. So 5% is 0.05. So 0.05 times 2,000. And then 1% of X is 0.01 times X. And then 2% is 0.02, and we're multiplying by 2,000 plus X. So there's our equation, and we're going to solve that for X. There's only one variable, and one equation and one variable we can solve. So I don't like decimals. I don't know about you, but I hate decimals and I hate fractions. And so my recommendation is to get rid of them right away. So when we have fractions in our equations, we get rid of the fractions by multiplying both sides by the least common denominator. It's the same idea with decimals, because a decimal is just a fraction where the denominator is 10 or 100 or 1,000 or some power of 10. So our fractions here, we have 0.05, which is 5 over 100. We have 0.01, which is 1 over 100. And we have 0.02, which is 2 over 100. So clearly, our least common denominator is 100. So I'm going to multiply both sides of the equation by 100 to get rid of all my decimals. Okay? So remember, on the left, you got to distribute, and well, that just means multiply each term by 100. So on the left, we just get 0.05 times 100 is 5. 0.01 times 100 is 1. On the right, 0.02 times 100 is 2. So I just got rid of all my decimals. I multiplied each of those 3 decimals by 100, which just means move the decimal over to the right 2 places. So now I'm going to just simplify a little bit. I'm going to do the multiplication. 5 times 2,000 is 10,000. So 10,000 plus x equals 4,000 plus 2x, just distributed on the right. And so now let's start getting all my x's together. So subtract x from both sides. I got 10,000 equals 4,000 plus x. Subtract 4,000 from both sides. And I've got 6,000 equals x. And now, because you're nervous, it's an exam, and I'm timing you, you might just circle that and move on. But you're not quite done. I want you to answer the question. And I want you to use words. So x represents the number of panels that plant B produced. So let's answer the question. Plant B produced 6,000 panels, and circle that as your final answer. Okay, so remember, the most important step in any word problem is the very first step, and that is to define all your variables. And you will get credit for that, even if that's all you do. And you will lose a point if you don't do that. If you write down an equation that has variables in it, but you never told anyone what those variables represent, then the equation doesn't really have any meaning. Okay. I'm going to pause for a second and answer a message that just came in. Okay, so let's look at the next question. Number 3 says factor. So it's a quadratic, it's a trinomial, and there's actually 2 methods here. There's the trial and error method and the AC method. And I'm going to do it both ways so you can see the difference, and you might have a preference. Either way will work. My preference is the AC method. Trial and error kind of drives me crazy because I never know how many possibilities there are, but you may like that. So let's look at trial and error first. So we start by setting it up. It's going to be 2 binomials, and the first term in each binomial, the 2 terms, have to multiply together to be 14x squared. So there's a couple different possibilities there. One is that it's x and 14x, okay? And so then the second term in each of the binomials, the second terms have to multiply together to be -6. And there's a couple of possibilities there too. So we could have -2 and +3. So that's one possibility. Let's multiply it together to see what happens. So x times 14x is 14x squared. Hang on. So 14x squared plus 3x minus 28x minus 6. And when we combine the middle terms, we get -25x. Okay, so the outer terms are fine, but the inside term needs to be +17x. It's this is negative 25x. So this isn't going to work for us. So let's look at another possibility. Let's keep the first two terms the same, x and 14x. And now let's see if we can do positive 2 and negative 3 instead of negative 2 and positive 3. Now when we multiply that together, let's FOIL it out, we get 14x squared minus 3x plus 28x minus 6. And then when we combine the middle terms, we just get positive 25x. So that doesn't quite work either. So let's try another possibility. Suppose we have 2x and 7x instead of x and 14x. Let's see what happens if we have a minus 3 and a plus 2. And multiplying those together, 14x squared plus 4x minus 21x minus 6. Well, when we combine those middle terms, we get negative 17x, and we want a positive 17x. Well, that tells me that I might be on the right track. So instead of a negative 3 and a positive 2, let's try switching those up a little bit. Let's try a positive 3 and a negative 2. We multiply this together, we get 14x squared minus 4x plus 21x minus 6. And voila, we do get a 17x in the middle. There are several more possibilities that I didn't try. I did 1, 2, 3, 4 possibilities, and the fourth one turned out to be the right one. Now, I think there's another 4 possibilities, but since I arrived at the right one, I don't have to check them. But what if you had done all 8 before you got to the one that worked? That would have taken a lot of time. Okay, so sometimes trial and error can be super time consuming, and if you're like me, you might get anxious about, have I done all the possibilities? How do I know how many there are? And so I hate that. I hate that anxiety. So I like to do it in a much more systematic way. Then I know I'm going to get to the right answer without messing around or wondering or having anxiety. So I like the AC method. And you learned the AC method in ALEKS, but you may have actually answered the questions without doing the AC method. So you can have a choice. You can do it any way that works. So let me show you the AC method. So in the AC method, you have to identify what A and C are in your trinomial. So A is the number in front of the x squared, and C is the constant term. So in this one, A is 14 and C is negative 6. So first what you do is you multiply A and C together. So A times C in this problem is 14 times negative 6, which is negative 84. Okay? And so now the next step is you want to find 2 numbers, I'm going to call them M and N, such that M and N multiply together to also be negative 84. So M times N is negative 84. And M plus N will add together to be positive 17, that middle coefficient. Okay? So 2 numbers that are different from A and C. They're not the same as A and C, but still multiply together to be negative 84, and then add together to be 17. So we start listing the possibilities. So I'm going to make a 2-column table, So the pairs, I'm going to start with the lowest number. So the two numbers, m and n, have to multiply together to be a negative, right? So that means one is positive and one is negative. And since, I'm sorry, they have to multiply together. Yeah, they multiply together to be a negative, right? But then they have to add together to be a positive 17. So the negative one has to be less than the positive one, because a negative number plus a positive number adding together to be positive means that the positive one is a little bit bigger. So I'm going to start with the smallest negative number, negative 1 times positive 84. Those two numbers multiply together to be negative 84, right? But when I add them, I get positive 83. That's not positive 17. So let's try the next one. So negative 2 times positive 42 is also negative 84. And when I add those two numbers together, I get positive 40. Still not the right number. The next one, does 3 go into 84? You can check. Yes, 3 will go into it. So let's try negative 3 times 28. When we add those two numbers together, we get positive 25. We're getting closer. We're getting close to 17. So the next one, let's try negative 4 times positive 21. Those two multiply together to be negative 84. And when we add them, we do get positive 17. So we've arrived at the right pair. The pair, MN, is negative 4 and 21. So what do we do with those two numbers? So what we do is we rewrite our polynomial, 14x squared plus 17x minus 6. We rewrite it by breaking up the middle term. 17x can be rewritten this way. So we're going to have 14x squared plus 21x minus 4x and then minus 6. So I took the two numbers, 21 and negative 4, and I used those two numbers to rewrite positive 17. I could have written it in a different order. I could have written 14x squared minus 4x plus 21x minus 6, and that would also work. So it doesn't really matter which order you write them in. Okay, so now what do we do with this? Now we use grouping. So grouping is a factoring method that you can use when you have 4 terms. And we have 4 terms. So let's group the first 2 terms together and the last 2 terms together and see if we can pull out a GCF from each of those pairs. So when I look at 14x squared plus 21x, I see that x can come out of both terms and also a 7. So the GCF in the first 2 terms is 7x. So factor a 7x out of the first term, I get 2x. And out of the second term, I'm left with 3. Now, in the last 2 terms, I have negative 4x minus 6. The GCF there is just negative 2. It could be positive 2. Well, whenever you're looking for a GCF and the first term or one of the terms is negative, it's usually best to factor out the negative GCF. So let's factor out a negative 2. And what am I left with in the first term? So negative 4x divided by negative 2 leaves us with a positive 2x. And then negative 6 divided by negative 2 leaves us with a positive 3. Now, what's great about this is we notice that both terms have a 2x plus 3. So that is our GCF from these 2 terms. So if we factor a 2x plus 3 out of the first term, we're left with just a 7x. If we factor the 2x plus 3 out of the second term, we're going to be left with just the negative 2. Okay, so now it's factored. And you can check your answer by foiling it back together. Make sure you get the right quadratic. So that's our final answer. That's the AC method and the trial and error method. Take your pick. Okay, the next question. Here's an absolute value inequality. We're going to solve it for x and graph the solution on the number line. So remember, with absolute value inequalities, you want to isolate the absolute value first. So here I'm going to add 5 to both sides, and I'm left with absolute value of 6x minus 3 greater than or equal to 9. Now, to take away the absolute value, I want to understand what I need to replace it with. So I always recommend drawing a little number line to see what's going on. So this absolute value always represents the distance from 0 of whatever's inside, right? So the distance between 0 and 6x minus 3 is greater than or equal to 9. So that means 6x minus 3 is somewhere out there or somewhere out there. The distance has to be greater than or equal to 9. So writing that down mathematically means we get two inequalities. Let's take away the absolute value, and we have to say 6x minus 3 is less than or equal to negative 9, or 6x minus 3 is greater than or equal to positive 9. Okay, and so now we solve these two separately. So here I can add 3 to both sides. I'm left with 6x is less than or equal to negative 6. Now divide by 6, and I'm left with x less than or equal to negative 1. And the other one is similar. Add 3. I've got 6x is greater than or equal to 12. Now I can divide by 6 on both sides. And x is greater than or equal to 2. Okay, so we've solved it, but now we have to graph it on the number line. So x less than or equal to negative 1 means we're including negative 1, so we put a solid dot there. And then we draw an arrow going down to the left. Okay, everything less than or equal to negative 1. And then for the other one, we draw a solid dot at positive 2 and an arrow going to the right. And that's our solution on the number line. All right, let's look at number 5. This one says graph the inequality 5x minus 2y less than negative 6. So graphing an inequality means shading in a region in the plane. And the region, the plane is divided into two regions. It's divided using a line, and we're going to shade in one side of that line. So the first thing we have to do is figure out what the line is and sketch it. And it's called a boundary line. So we get the equation of the boundary line by taking this inequality and replacing the less than with an equal sign. So the boundary line has equation 5x minus 2y equals negative 6. And now what I'm going to do is rewrite it using slope-intercept form. So negative 2y equals negative 5x minus 6, and then divide both sides by negative 2, and I get y equals positive 5 halves x plus 3. Now why did I do it like that? Because it's easier to graph if I know the slope and the y-intercept. So slope is positive 5 halves, and then the y-intercept is going to be positive 3. Okay, so we're going to sketch the line, but we have to decide if it's going to be solid or dotted. And we look at that symbol and we see it has to be dashed or dotted because it's not less than or equal to. So we're shading in a region in the plane, and we want to make sure we're not including the points that lie in that line. So let's sketch the line y equals 5/2 x plus 3, but make sure it's a dashed line or dotted line. So the first thing we do is plot the y-intercept at 0, 3. And then I want to use the slope, rise over run. So that means I want to go up 5 and over to the right 2. So up 5 and over 2 gets me there. And I just drew the line really quickly. Sorry about that. And I made it a dotted line. So I actually plotted 3 points. You only need 2, and drew the line. All right. So now we're not done. We know we're going to shade either the left side or the right side of this line. To figure out which side to shade, we choose a test point. Choose a point that does not lie on the line. So the easiest one to use, as long as it's not on the line, is the origin, the point 0, 0. And looking at my graph, I can see that my line does not go through the origin, so I can use that. So I'm using the test point 0, 0. And I'm going to take that point and I'm going to plug it into not the equation, but the inequality. So I have to go back to the inequality 5x minus 2y less than negative 6 and plug in x equals 0 and y equals 0 and see if it's a true statement. So 5 times 0 minus 2 times 0 less than negative 6, question mark. Is that true? Well, the left side is 0 minus 0, the right side is negative 6, and that's clearly a false statement. So that means that that test point is not going to be in the region that we're shading. So that means we have to shade the other side of that line. So we're going to shade the side that does not contain 0, 0. So there's our solution, our graph. Okay, let's look at the next problem. Number 6, long division problem. All right. This one, it looks, it's got some complications to it. I have a lot of minus signs. Also, I can see that my dividend, the polynomial, the big one that's being divided, is not in descending, strictly descending degree. It's kind of out of order. So I'm going to have to rewrite that so all my powers are going down from left to right. So let's set up the division. So the divisor, the dividend. So I'm rewriting so that all my powers are going down and nothing is out of order. Negative 9x to the 4th plus 15x to the 3rd minus 18x squared plus 11x minus 4. Okay, I got all my minus signs, yeah. So now we look at the leading terms. Negative 9x to the 4th divided by negative 3x squared is positive 3x squared. And I write it above the x squared term. And that's not a big deal if you don't do that. That's okay. And then we do the multiplication. 3x squared times negative 3x squared is negative 9x to the 4th. 3x squared times negative 4 is negative 12x squared. And notice I'm inserting a placeholder because there was no x to the third term, so I'm inserting a 0x to the third in there, and that's not necessary either, but it might be useful for some people, so that's why I'm doing it. And now I want to subtract, so use parentheses and a minus sign. And I know some people like to distribute that minus sign, but it's kind of dangerous because people tend to forget to change all the signs, and it will be hard for me to tell. That's a mistake that I cannot find when you do it that way. So I would leave it like this and do the subtraction in your head term by term. So what I mean is, in your head, you say negative 9x to the fourth minus negative 9x to the fourth is 0. And then you go to the next term. 15x to the third minus 0x to the third is 15x to the third. And the next one, negative 18 minus negative 12 is negative 18 plus 12, which is negative 6. So really, you're just subtracting the coefficients. The next one is 11x minus 0x. 11 minus 0 is 11. And then negative 4 minus 0 is negative 4. Okay. So now we do it again. 15x to the third divided by negative x squared is negative 5x. And we do the multiplication. So negative 5x times negative 3x squared is positive 15x to the third. And then negative 5x times negative 4 is positive 20x. And then since I skipped an x squared, I'm going to insert a little placeholder there. And then negative, oh, that's it. So let's do subtract. Okay. Term by term, 15 minus 15 is 0. Negative 6 minus 0 is negative 6. 11 minus 20 is negative 9. Negative 4 minus nothing is negative 4. Okay. So now we do it again. So we've got negative 6x squared divided by negative 3x squared. And that is positive 2. And positive 2 times negative 3x squared is negative 6x squared. Positive 2 times negative 4 is negative 8. And so I'm going to do my little placeholder thing, which, as I said, is not necessary. And now I'm going to subtract term by term. And I'm just going to subtract the coefficients. So negative 6 minus negative 6 is nothing. So there's no x squared term. Negative 9 minus 0 is negative 9. Negative 4 minus negative 8 is negative 4 plus 8, which is positive 4. Okay, so now we look at the leading terms and we see that we can't divide. Negative 9x can't be divided by negative 3x squared. So we're done. So this is our remainder, and the quotient is the thing on top, 3x squared minus 5x plus 2. And the instructions say write your answer in the form quotient plus remainder over the divisor. So the quotient was 3x squared minus 5x plus 2. And then the remainder was negative 9x plus 4. We're putting that over negative 3x squared minus 4. And that's the answer. Okay, another word problem. Use algebra to solve. Circle your final answer. So this one says a motorboat takes 4 hours to travel 128 kilometers going upstream. The return trip takes 2 hours going downstream. What is the rate of the boat in still water, and what is the rate of the current? So, two unknowns here. Always the first step is to define your variables. So we're going to have two of them. The rate of the boat in still water and the rate of the current. So let's use x and y again. You can use whatever you want. But x is the rate of the boat in still water, not the boat. It's the rate of the boat. And y is going to be the rate of the current. Y is not going to represent a current. It's going to represent the speed of the current. Okay, be precise. So we're going to have two equations. Whenever you have two variables, the only way to solve for two variables is to have two equations. So let's use a table to organize our work. We're going to have one equation involving the trip upstream and another one involving the trip downstream. And in this type of problem, we're going to use distance, rate, and time. So my two rows are going to be the two different trips, upstream and downstream. My columns are going to be distance, rate, and time. And we're going to fill in boxes with things that we know and things we don't know. So first of all, let's write down the equation that comes in handy. Distance equals rate times time. Sometimes I just have to write it down. I have it in my head, but visually I just need to see it while I'm doing this. So write that down. D equals RT. So let's fill it in. The times for the two trips are 4 hours and 2 hours. So it took 4 hours to go upstream and 2 hours to go downstream. Now, the rate going upstream. Well, the boat is going against the current, right? So it's the rate of the boat, x kilometers per hour, but the current is kind of holding it back. So we're going to subtract the rate of the current from the rate of the boat when we're going upstream. So it's going to be x minus y, the rate, overall rate, the speed going upstream is the rate of the boat in still water minus the rate of the current because it's pushing it back. And then when the boat is going downstream, the current is helping it along. It's going faster than it would in still water. So it's the rate of the boat in still water plus the rate of the current. So it's x plus y. So now what are we going to put under distance? Well, that's where we're going to use distance equals rate times time. So going upstream, the distance is 4 times x minus y. So the rate, x minus y, times the time, 4 hours. And then going downstream, it's going to be 2 times x plus y. Okay, so now our equations, we're going to use the distance in the distances in the distance column, and the fact that we know the actual distance is 128 kilometers. So let me circle that up here. Both trips, the distance is 128 kilometers. So we can write down 4 times x minus y equals 128. And we can write down 2 times x plus y equals 128. And now we have a system of 2 equations and 2 variables. So let's distribute, let's distribute. 4x minus 4y equals 128. And 2x plus 2y equals 128. All right, so now I want to eliminate a variable. So maybe adding 2 equations together would do that, except I don't have the right coefficients. So if I take the second equation and multiply everything by 2, I get a new system. 4x minus 4y equals 128, and 4x plus 4y equals 256. And now notice I can add those two together and eliminate the y variable. So I get 8x equals 384. And if I divide both sides by 8, I get x is 48. So that's one of my variables. So I take that, x equals 48, and I plug it into one of the equations to get y. And it shouldn't matter which equation. So let's do the 2 times x plus y equals 128. Plugging in 48 for x. And now this is something I should have done earlier, but I can divide both sides by 2. Instead of distributing the 2, let's divide both sides by 2, or multiply both sides by 1/2, and then I can get rid of that 2. So I get 48 plus y equals 64, and subtract 48 from both sides, and I get y equals 16. So now I can go back and answer the question, and I want to use units. So the rate of the boat in still water, that was x, so that's going to be 48 kilometers per hour. And then the rate of the current, that was y, that's going to be 16 kilometers per hour. And there's my answer. All right, let's go on to number 8. Number 8 is a division problem, dividing 2 rational expressions. So remember, when you're dividing fractions, you take the divisor, you flip it over, and change it to multiplication. So that's what we're going to do here. The divisor is the thing you're dividing by. So this division problem is the same as this multiplication problem. 5x squared minus 17x plus 6 over x plus 1 times 7x minus 8 over 3x minus 9. So now, before we do the multiplication, we always want to factor and cancel. So factoring 5x squared minus 17x plus 6, we get 5x minus 2 times x minus 3. So then 7x minus 8 can't be factored, so we have to leave that one alone. 3x minus 9 is 3 times x minus 3. So notice, before we multiply, we've got some cancellation, not much. Those two things cancel. We're left with 1s there. And so now we just multiply straight across, and you can just leave it in factored form. So we get 5x minus 2 times 7x minus 8 all over 3 times x plus 1. And don't multiply those things out, just leave it factored. Okay, let's go on to number 9. So number 9, we're solving an inequality for the variable v. So it's a simple linear inequality. Simplify your answer as much as possible. So notice all those fractions and minus signs. So I strongly recommend getting rid of the fractions. I know everybody knows how to find the least common denominator and add fractions together or subtract them after getting the least common denominator, but most of us make more mistakes when we do that, adding and subtracting fractions, even after we find the least common denominator. You're more likely to make mistakes when you do that. So I highly recommend using the least common denominator. Just get rid of the fractions. So we get rid of the fractions by multiplying both sides of the inequality by the LCD. So the LCD here is going to be 24. Both 8 and 6 go into 24, and that's the smallest number that they both go into. So now let's take that inequality and multiply both sides by positive 24. So I'm writing it out. And since I'm multiplying by a positive number, I don't have to change the inequality symbol. I don't have to reverse it. So this is the part where people also make mistakes. They forget to distribute and cancel separately. So do not cancel yet until after you distribute that 24. So we've got 24 times negative 9/8 v minus 24 times 1 is greater than 24 times 5/6 v plus 24 times 3/8. So I'm avoiding the common mistake that people make, which is they cancel too soon and they cancel the wrong thing. So now I cancel separately. So the first fraction, 8's cancel. I'm left with a 3 and a 1. On the right side, that first fraction cancel the 6's. I'm left with a 4 and a 1. In the second fraction, the second product, cancel the 8's. Left with a 3 and a 1. So now I've got 3 times negative 9v, which is negative 27v, minus 24 is equal to 4 times 5v, which is 20v, plus 3 times 3, which is 9. So I've gotten rid of all the fractions. I've canceled separately because I distributed that 24. I avoided a very common error. So now I want to get all my v's together and all my constants together. So let's add 24 to both sides. And I'm left with negative 27v greater than 20v plus 33. Now let's subtract 20v from both sides. And we're left with negative 47v greater than 33. Now I want to get v by itself, so we have to divide both sides by negative 47, which is fine, except be very careful. You have to reverse that inequality because you just divided by a negative number. So remember, when you're dividing or multiplying an inequality by a negative number, that means you have to reverse the direction of the inequality. So we're left with a v less than negative 33 over 47. Notice I put that minus sign on top. It doesn't matter. Usually we write the minus sign in the numerator or right out in front of the whole fraction, but it's not wrong to leave it in the denominator. Okay, so that's our final answer. We're simplified as much as possible. I can't reduce that fraction anymore. All right. Number 10, we're finding the domain of a radical function. And we have to write the answer in interval notation. So the domain means all the possible x values that are legal, all the numbers that we can plug in for x and get a real number answer. So to get a real number, when we take the square root of something, means that the thing inside the square root has to be non-negative. So the thing inside the square root, 54 minus 9x, can't be negative. So let's figure out what that means. That means 54 minus 9x has to be greater than or equal to 0. So equal to 0 is fine because we can take the square root of 0. So let's solve that inequality. So subtracting 54 from both sides, I'm going to be left with negative 9x greater than or equal to negative 54. And now I have to divide by negative 9 on both sides. And remember, that means we have to reverse that inequality. So we're left with x is less than or equal to positive 6. And we're going to graph that on the number line. So less than or equal to means we're including positive 6, so we have a solid dot at 6, and we're going down. So we draw the arrow going left. Okay. Oh, and yeah, forgot. You have to write this in interval notation. I drew it on the number line to help me write it in interval notation. So we use a square bracket around the positive 6, meaning we're including that number in our answer. And we always use round parentheses around infinity or negative infinity because we never include that. It's not a real number, so we can't use a square bracket next to negative infinity or positive infinity. Okay, let's look at the next one. All right, so this one is 2 parts. We're given a line, y equals 5x minus 1, and we're asked to find equations of 2 other lines. The first part, part A, says find the equation of the line that is perpendicular to this line and passes through the point 8, negative 5. And then part B says find the equation of the line that is parallel to this line and passes through the same point, 8, negative 5. All right, let's look at part A first. So here we're looking for a line that's perpendicular to the given line. What does that mean? Well, the given line has slope positive 5. So the line that's perpendicular to it has to have slope negative 1/5. It has to be the opposite reciprocal. The slopes have to multiply together to be negative 1. So if the given line has slope 5, then the perpendicular line has to have slope negative 1/5. All right, so now we got to find the equation. The easiest thing to do is to find the equation in slope-intercept form. And so that looks like this. Y equals mx plus b, where m is the slope and b is the intercept. Well, we already know the slope, so let's put that in there. It's going to be y equals negative 1/5 x plus b, some number b. Well, we have to find it. So to find the number b, we're going to use the given point. The line has to contain the point 8, negative 5. So those coordinates, x equals 8 and y equals negative 5, those have to satisfy the equation of the line. So let's use those coordinates and to try to find the number b. So plugging those two numbers in here, we get negative 5 equals negative 1/5 times 8 plus b. And simplifying just a tiny bit, we get negative 5 equals negative 8/5 plus b. So we can solve that for b. Let's add 8/5 to both sides. And getting a least common denominator, that's negative 25/5 plus 8/5. And that gives me negative 17/5. That's the number b. So now we can put it all together and write the equation y equals negative 1/5 x minus 17/5. That's the line perpendicular to the given line, passing through the point 8, -5. Okay, so I've noticed in past semesters when I've given this problem on tests, students tend to doubt themselves when they get weird numbers like -17/5. And it looks like I wrote a 6 there. That should be a 5. Let me change that. Students tend to freak out when they see that number and they cross it out and they move on to the next problem. They think they don't know what they're doing. So don't freak out if you get a weird fraction like -17/5. It's perfectly fine. All right, let's look at part B. Part B says, find the equation of the line that is parallel to the given line and passes through the same point, 8, -5. Okay, so we're going to do the same thing, but here, parallel means they have the same slope. So the line we're looking for has slope 5, okay? But it's not going to be the same equation of the given line. It's a different equation, but they're going to have the same slope. So we're going to write down our equation in y = mx plus b form, but instead of m, we're going to have a 5. Okay, and we're going to use those two coordinates, x = 8 and y = -5, in order to figure out what b is. So let's plug those in. So we get -5 = 5 times 8 plus b. Simplifying, we get -5 = 40 plus b. Subtract 40 from both sides. And we get -45 = b. And so now we're done. We put it all together. Y = 5x minus 45. That is the equation of the line parallel to the given line, but going through the point 8, -5. All right, let's move on. Number 12. We have an absolute value equation. We need to solve it for u. So remember, we've got two absolute values. So there's two situations going on here. When two numbers have the same absolute value, that means that they're the same distance away from 0. They could be the same number. So 2u minus 6 equals 2u minus 3, or they could be opposites of each other. 2u minus 6 equals the opposite of 2u minus 3. Okay, so we get two equations when we take away the absolute value. Either the things inside are exactly the same, or the things inside are opposites of each other. So we solve these separately. So let's add 6 to both sides of that one. We get 2u equals 2u plus 3. And then if we subtract 2u from both sides, we get 0 equals 3. So that's a false statement. That can never happen. No matter what u is, we can't get 0 equals 3. So that equation gave me no solution. Bummer. But we're not done. Let's go back to the other equation. 2u minus 6 equals the opposite of 2u minus 3. Let's distribute the minus sign on the right. We get 2u minus 6 equals negative 2u plus 3. And now let's add 6. We get 2u equals negative 2u plus 9. And let's add 2u to both sides. So we get 4u equals 9. And we can divide both sides by 4. And we're done. U is 9/4. And that fraction is simplified. So don't forget, when you have an absolute value equation where you have two absolute values and they're both isolated, you have to break it into two equations when you take away the absolute value. The two equations say the two things inside are the same number, or the two things inside are opposites of each other. All right. Number 13. Another absolute value equation, but we only have one absolute value. 4 times the absolute value of y plus 5 minus 24 equals negative 16. So the first goal is to isolate that absolute value. So adding 24 to both sides gives me 4 times absolute value of y plus 5 is equal to positive 8. And now let's divide both sides by positive 4. And we get absolute value of y plus 5 equals 2. And now there's two possibilities, right? When the absolute value of a number equals 2, that means that number could be 2 or it could be negative 2. There's two possibilities. So when we take away the absolute value, we've got two situations. Y plus 5 is negative 2, or y plus 5 is positive 2. And let's solve them separately. So subtracting 5 here gives me y equals negative 7. And the other one, subtracting 5, gives me y equals negative 3. And so my two possibilities are negative 7 or negative 3. All right, another word problem. And again, it says use algebra to solve. So that means we're going to declare a variable or variables, and then we're going to set up an equation. We're going to solve the equation and then answer the question. And here it says do not do any rounding. So that means, and I suggest this for all problems, don't use your calculator. When you've got fractions, leave them as fractions. Because often when you put a fraction into a calculator, you get a decimal that goes on forever, but you have to chop it off. And so when you chop it off, you've rounded, and that's not an exact answer. So let's leave our fractions alone. So this one says Jessica drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 6 hours. When Jessica drove home, there was no traffic, and the trip only took 4 hours. If her average rate was 22 miles per hour faster on the trip home, how far away does Jessica live from the mountains? All right, so we're going to have to organize this information. It's a lot. There's a lot going on. This is another distance equals rate times time problem. So first, we have to define a variable. So what are we looking for? We're looking for the distance that Jessica lives away from the mountains. How far away does Jessica live from the mountains? So I'm going to let my variable x equal the distance from her house to the mountains. All right, and so now in order to come up with an equation, we're going to have to organize the information. So we've got 2 trips. We've got to and from the mountains. So those are going to be my 2 rows in my table, to the mountains and from the mountains. The columns are always distance, rate, and time. It doesn't matter which order. Okay, now let's start filling it in. So the distance in both trips is x, because she went to the mountains and she went home. She didn't add any distance in either trip. So her time, let's see, the times were 6 hours and 4 hours. So now we're going to use those 2 columns that we've already filled in to fill in the middle column. So we know distance equals rate times time. So what does that mean about the rate? Well, you can divide both sides of this equation by t, and you get d over t is equal to r, or r equals d over t. And that's also intuitive, right? The rate, she's driving miles per hour. Yeah, rate is miles per hour. That's miles divided by hours. That's distance divided by time. So rate is always distance divided by time. So her rate going up to the mountains is her distance x divided by her time, 6 hours. The rate coming home is her distance x divided by 4 hours. Okay. So now we have to set up an equation. We haven't used some important information. So going back to the problem, it says her average rate was 22 miles per hour faster on the trip home. So let's write an equation saying that her rate coming home, on her trip home, the rate coming home was x over 4, and that's 22 miles per hour faster than the rate going to the mountains. So x over 4 is 22 plus x over 6. Okay, so x over 4 was her rate coming home, and it's saying that that's 22 miles per hour faster than her rate going up. So it's 22 plus x over 6. Okay, and so now I like to get rid of fractions, so I'm going to find the LCD, which is 12. Both 4 and 6 go into 12, and it's the smallest number they both go into. And now I'm going to multiply both sides of my equation by 12 to get rid of the fractions. So on the left, I cancel the 4s. On the right, I'm going to distribute before I cancel. So I've got x over 6 times 12 plus 22 times 12. I wrote them in a different order, but that's okay. I don't know what my brain thought just now. All right, so when I cancel here the 6's, I'm left with a 1 and a 2. There's no cancellation in 22 times 12. I just have to multiply that. So I have 3x equals 2x plus 22 times 12 is 264. Now all I have to do is subtract 2x, and I'm left with x equals 264. And I'm not going to circle that as my answer. I'm going to write my answer. She lives 264 miles from the mountains. And circle it. Boom. Okay. All right. So the key here was to define a variable, organize all the information. There are 2 trips going up and coming back. Filling in the table, 2 of the columns filling in with the information that's given, and then the 3rd column we filled in using distance equals rate times time, or rate equals distance divided by time. And then coming up with an equation using the rest of the information that was given in the problem. Okay, let's look at the next one, number 15. Solving a compound inequality, and it's 4u plus 2 is greater than negative 14, and 3u plus 3 is less than positive 18. And we have to write the solution in interval notation, and if there's no solution, we're going to use the empty set symbol. All right, so this one is simple. We just have to solve the 2 inequalities separately. So 4u plus 2 greater than negative 14. I'm going to subtract 2 from both sides. 4u is now greater than negative 16. And now divide by 4 on both sides. And I get u is greater than negative 4. And the second one, 3u plus 3 is less than 18. Subtract 3. I'm left with 3u is less than positive 15. Now divide by 3. And I have u is less than 5. And now we have to write it in interval notation. So you have to somehow write as in interval notation. It could be a union of two intervals, an intersection of two intervals, but it's got to be interval notation, and it represents all the numbers that are greater than -4 and less than 5. So I suggest picturing it on a number line. So I'm going to draw the two inequalities separately on two separate number lines. So u greater than -4 on one number line, and then u less than 5 on another number line, and line them up. So notice they both have a -4, a 0, and a positive 5, and they're lined up, one right above the other, because we want to visualize what's going on. And then I'm going to draw a third number line that's going to represent all the numbers that are on both of the previous two number lines. So the third number line looks just like the first two. So what am I looking for? Well, let's look at the first number line. All the numbers strictly greater than -4. That means we're going to have an open circle at -4 and an arrow going up to the right. The second number line, we want all the numbers u strictly less than 5. So we want a circle, an open circle at 5, and an arrow going down to the left. So in the last number line, I want the numbers that are on both of the first two number lines. So what I'm looking for is the intersection of the two previous number lines. So is -4 in both sets? No, -4 isn't in the first set. It is in the second one, but it's not in the first. And similarly, positive 5. It is in the second set, but it's not in the first set. So we have to exclude both -4 and positive 5. And we want to include all the numbers in between those two. So the intersection is those numbers. Okay? So drawing all the number lines one above the other. Don't draw all the sets on the same number line. Draw them each, so u greater than -4 and u less than 5. Those two inequalities each get their own number line. And then the final number line is going to be separate. I'm going to draw it right underneath the other two. This is my recommendation so that you can visualize what's going on. So now that we have the number line, the solution set graphed on the number line, we can write down the interval notation for that solution. So we're not including -4 and we're not including positive 5. So we're going to use regular round parentheses. So it's the open interval from -4 to positive 5. So we're not including the endpoints. There's our answer. Okay, so that was number 15. Let's look at 16. All right, so 16 is a system of equations, and it's a 3 by 3, meaning we have 3 equations and 3 variables, x, y, and z. So what we do when we have a 3 by 3 is we use elimination to eliminate one of the variables and also get down to 2 equations. So then we reduce it to a 2 by 2, 2 equations and only 2 variables. So what we're going to do is take a pair of these equations, take 2 of them, and eliminate 1 variable. Use those 2 equations to eliminate 1 variable. And I see that the first 2 equations, right away, I can see that if I add those 2 together, the z's will go away, and I'll end up with 1 equation with just x and y in it. So let's do that. Let's add those 2 equations. 2x plus x is 3x. Negative y plus 3y is 2y. Z plus negative z is nothing. And then negative 3 plus negative 2 is negative 5. Okay, so now what we have to do is get another equation that only has x and y in it. We have to eliminate z again, but using a different pair of equations. So we have a couple different choices, but I notice here that if I use the first equation and the last equation, I can get rid of z if I multiply the first one by 3. Okay, so I have to use a different pair of equations, but I have to eliminate the same variable. Since I already got rid of z, I have to get rid of z again, but I have to use two different equations. So I'm going to take the first equation and the third equation. I'm going to multiply the first one on both sides by positive 3. And then I'm going to add these two together. So let me rewrite. The first equation is 6x minus 3y plus 3z equals negative 9. The second equation is staying the same, negative 4x plus 2y minus 3z equals 1. And now I'm going to add the two equations. So 6 minus 4 is 2, negative 3 plus 2 is negative 1. 3 minus 3 is nothing, and then negative 9 plus 1 is negative 8. So I get 2x minus y equals negative 8. So now I have two equations with two variables, x and y. So let's rewrite both equations. The first one is 3x plus 2y equals negative 5. The second one is 2x minus y equals negative 8. This is our new system. And now I want to get rid of one of the variables. So I notice that if I multiply the second equation by 2, I'm going to be able to get rid of y. So let's rewrite this system. 3x plus 2y equals negative 5. The second equation turns into 4x minus 2y equals negative 16. And when I add these together, I get 7x equals negative 21. And now all I have to do is divide both sides by 7. And I get x equals negative 3. All right, so now we have to take that value for x and plug it into some equation to get one of the other variables. So I'm going to use it to get y. I'm going to plug it in to 3x plus 2y equals negative 5. So we get 3 times negative 3 plus 2y equals negative 5. So that's negative 9 plus 2y equals negative 5. And let's add 9. And now let's divide by 2. And I've got y equals 2. And so now I have two variables. I need to find the third one, so let's choose one of the original three equations and plug in negative 3 for x and 2 for y. So I'm going to choose the first equation, so 2 times negative 3 minus 2 plus z equals negative 3. That was the first of the original equations. I plugged in negative 3 for x and 2 for y. And so I've got negative 8 plus z equals negative 3. Adding 8 leaves me with z equals 5. So if I just left it like this, if you just leave it like this, your teacher is trying to find your answer and she's looking all over. It's nice that you wrote all those arrows. So notice I'm drawing arrows. I'm telling the reader, start here, then go here, then go here. But don't leave it like this. Either circle x equals -3, y equals 2, and z equals 5, or rewrite your answer. So I'm going to rewrite my final answer, x equals -3, y equals 2, z equals 5. Okay, make it easy for me to find your answer and not go hunting. All right, we're almost done. Let's go to number 17. So number 17, for each graph below, state whether it represents a function. We're just going to circle yes or no. So it is, there's no work to show, really. Well, there is work to show. What am I saying? So what we're going to use is called the vertical line test. The vertical line test, when we're given a graph, we can test the graph to see if it's a graph of a function using vertical lines. The vertical line test says that the graph represents a function if there's no way that a vertical line can cross it more than once. Okay, so we can't find a vertical line that will intersect the graph more than once, then it has to be a function. So let's look at part A. So I want to see your vertical lines. Don't just guess. So if you just circle a yes or no and it looks like, and you don't show me why, then I can't tell, and it looks like you guessed. So I want to see your reasoning. So in the first one, part A, we have a triangle. I draw one vertical line and boom, I can see it crosses the graph more than once. So the answer there is no, it's not a function. Part B, I'm going to draw a vertical line there, just 1 point, another, just 1 point, 1 point, 1 point. There's no way I can draw a vertical line and cross it twice. Every vertical line I draw crosses the graph at most one time. Okay, so that one, yeah, that's a function. Part C, let's draw a couple of lines. Oh, well, there's a line that crossed the graph twice. I don't need to draw any more lines. I found one line, vertical line, crosses the graph twice, no function. Okay, part D, I draw a line there, just crosses once, a line there, and it looks like there's no way I can find a vertical line that will cross this thing twice. So yeah, that's a function. Part E, I can draw a vertical line easily that crosses twice, so that's not a function. How about F? F is a little weird. It's just 3 line segments. 2 of the line segments have endpoints that are included. One of the line segments has open circles, so those endpoints are not on the graph. So let's draw some vertical lines. Now that line can only intersect the graph once. Now this line looks like it goes through 2 points, but really it doesn't. It only goes through 1 point because that open circle is not a point. So this one only intersects it once. If I draw a line across any of the line segment parts, it will only cross once. That one crosses the graph at only 1 point. This one crosses the graph at only 1 point. I can tell that there's no way I can draw a vertical line that will cross the graph in more than 1 point. I can just keep moving my lines around and they're never going to cross in more than one place. So this one is definitely a function. Okay, so show me some vertical lines. Make sure I can tell that you're not guessing. All right, let's go to number 18. 18 says solve for u, and it says 2u squared minus 5u plus 19 equals u minus 5 squared. So this is a quadratic, but it's not simplified. And in order to solve it, we need to have a 0 on one side and get everything else on the other side and combine all our like terms. Well, in order to combine any like terms, we have to square out that u minus 5 squared on the right-hand side. So let's do that. So the left side I'm leaving alone. The right side is u squared minus 10u plus 25. So now let's get everything over on the left so that we get a 0 on the right, because we want to use either the quadratic formula or factoring. Okay? And factoring, we use factoring because we can use the zero product property. But to use the quadratic formula or the zero product property, we have to have a 0 on one side. You can't have anything but 0. You can't have a number, you can't have another polynomial. So that's our goal right now. So let's start subtracting. Let's subtract u squared from both sides. Let me also add the 10u to both sides. And let me subtract 25 from both sides. And when I do that, I'm left with u squared plus 5u minus 6 equals 0. And I can use the quadratic formula, but this one is easily factored. It's u plus 6 times u minus 1 equals 0. And the zero product property says when you have two things multiplied together to equal 0, then at least one of those things had to be 0 to begin with. So u plus 6 is 0, or u minus 1 is 0. Okay, so now let's subtract 6 from both sides of this one. We get u equals negative 6. The other one, I just add 1 to both sides, and I get u equals positive 1. And that's my final answer. Now, one thing that we haven't been doing is I haven't been checking my answers, and I hope that you guys know how to do that. You can do that as you go, or you can do that at the end after you finish the exam. Go back, and to check your answers, you just plug your answers back into the equation in most of these problems. Or if it's an inequality, you can't plug in the answer, but you can plug in 1 or 2 numbers that are contained in the solution set. All right, so we're almost done here. Let's do number 19. This one just says simplify y to the negative 3 raised to the 7. And we have to write our answer without negative exponents. So this is the power property of exponents. We're taking a power of y and raising it to another power. So the way to deal with that is to multiply those two exponents. So we get y to the negative 21, negative 3 times 7. Now we're done, except for our answer isn't in the right form. So y to the negative 21 is just 1 over y to the positive 21. So that negative exponent just means flip it over and change the sign of the exponent. All right, the last problem. Oops. Number 20. Graph the equation y equals 6 times absolute value of x minus 7. All right, so in graphing an absolute value equation, it's really important that you don't just plot random points, because you could accidentally choose points just on one side of the vertex and think you've got a straight line, and when you connect the dots, you've connected them. You've kind of assumed something that wasn't correct. So, graphing an absolute value equation, remember that the graph is always going to be a V or an upside down V. And the point where the V is, where it comes together in a point is called the vertex. So the first thing you're going to do is find the vertex. And to find the vertex, you look at what's inside the absolute value. When the inside of the absolute value is 0, that value of x gives you your vertex. So our vertex is going to happen at the place where x minus 7 is 0. So if I solve that, I get x equals 7. So that's the x coordinate of the vertex of my graph. So what I'm going to do is find the y coordinate that goes with that, but also I'm going to find 2 more points on the graph. They're going to be the points on either side of the vertex, one on the left and one on the right, and that's it. We just need 3 points. We don't need any more than that. So we're going to make a short table with our x coordinates and our y coordinates. So the first x coordinate we're going to use is the vertex, the x coordinate of the vertex, which we said was 7. Now on the left is going to be x equals 6, and on the right is going to be x equals 8. You could choose any number on the left and any number on the right, but these are the 2 closest, 6 and 8. So let's find the y coordinate of the vertex. The y coordinate of the vertex we get by plugging in 7. So we get 6 times the absolute value of 7 minus 7. Well, 7 minus 7 is 0. We knew that. And the absolute value of 0 is 0. So 6 times 0 is 0. So the y coordinate of the vertex is 0. So when x is 6, the y coordinate is 6 times the absolute value of 6 minus 7. 6 minus 7 is negative 1, but the absolute value of negative 1 is positive 1. So we get 6 times positive 1, which is 6. So the y coordinate that goes with 6 is 6. The y coordinate that goes with 8, we plug in 8, we get 6 times absolute value of 8 minus 7. 8 minus 7 is 1. The absolute value of 1 is 1. So again, we have 6 times 1, which is 6. So let's plot the 3 points. The vertex is 7, 0. So x equals 7 and y equals 0 is right there. And then on the left, we get the point 6, 6. So x equals 6 and y equals 6, so we get that point. And then the third point was 8, 6. When x is 8, y is also 6. All right, so we've got the 3 points, and we get our v like that. All right. So when you're graphing an absolute value equation, make sure you find the vertex. That's the point where the v comes together. And just a little tip, when the number outside the absolute value is positive, so in this case we had a positive 6 outside the absolute value, the multiplication, the coefficient, it's being multiplied by a positive 6, that tells us it's going to open upward. If that were a negative 6 out in front of the absolute value, it would be an upside down V. It would be going down. That's just a little heads up, so when you're checking to see if your answer makes sense, you know ahead of time what it should look like. Okay, those are the solutions. That was a really long video. If you have any questions about the exam, and the exam is not going to be just like this. The exam will be 20 questions, but they're not going to be the same 20 questions. So there'll be different questions on the exam tomorrow. But this was a practice test. This is material you should know. And this is, I wanted you to have an idea of what it was going to feel like to take a test. So I hope that you've already taken this practice test and that you've timed yourself and that you did all the problems without looking at notes or videos or asking for help, just to get a sense of what it's going to be like tomorrow. Okay, great. If you have any questions, like I said, let me know. I'll be checking my messages all day. I'll be online again this evening, but if you want to talk to me before tonight, just send me a message and we can hopefully set up a time to talk. All right, if I don't hear from you tonight, I'll see you guys tomorrow.